Lady who?
Hey, stop yodeling.
You can't stop me.
Oh shit.
Yodel, yodel, yodel. Yodel, yodel, yodel.
Do we have the interface turned on? Okay. Well, we always have a great track record on these live streams, don't we?
We do, yeah.
Did you see my message about the computer stuff?
I did, yeah.
Okay, cool. I didn't know if it was like worth adding to the stream or not.
I think you could talk about it, yeah.
Okay, sure.
Because you're the one that's been experimenting with it.
Okay, sure.
I haven't done much with it.
Right.
But I can give the background on what we tried to do.
Yeah,
if we want to.
Okay.
Wow.
How many people do we have?
60 people.
Holy smokes. I don't even know 60
Lots
people.
of echo yodel. Is it possible to make it so that the view of us is bigger and then the view of the camera is like smaller and maybe in one of the corners? Oh. Oh, it's back. You can like overlay them on top if you want. Yeah. Yeah. Like overlay them on top if you want. Yeah, you can take the one with the board and you can put it on top of like, there's like a big white space up here that you put it.
People are here for the yodeling content.
Oh, you can't? Oh, that sucks.
All right.
Okay, well, just make us bigger for now, and then if I do anything here, you can make it bigger over here. Oh, you can't? Okay.
All right, we got like over 30
Okay. I think that's
SLBs.
I think that's all good, right? Okay.
Cool.
Well, welcome everybody. Chris and Andy here.
I'm the host.
Andy's gonna ask me questions based on questions you guys have sent in on all of our past SuperLongBoard update videos, and I will answer them, and maybe some of them Andy will answer. Johan was so very nice, set up a Mark II with the SuperLongBoard here. It's the same one that you've seen in some of the update videos, but what's different is that in all the other update videos, there was a ton of stuff back there, the whole rest of our workshop. But literally our entire office is moved now, except this one area. So
it's like abandoned warehouse.
Yeah.
Vibes.
Originally, I had an idea when we started the live stream that the camera would start like way back there, and then you'd see us sitting in this big empty room, and then we would zoom it in, but we couldn't do that. But that's okay. I think you get that picture. So if you guys don't know this already, the pre-orders are already live for the SuperLongBoard, so you don't have to wait for us to say a magic word or anything. Andy set it up.
Yep.
So it's good to go.
Yeah, I think we have just over 30 people pre-ordered since we launched it like half an hour ago. So yeah, thank you for the first batch of people.
Mm-hmm.
I'm sure we'll have more come through as we do the live stream.
Yeah.
Yeah.
We don't have anything in particular planned to show you guys because I already tried to make the update videos reasonably dense with what the board can do with demos and stuff like that. So if you haven't seen those, you can go check them out. And if there's anything that you do still want to see here, we're going to answer questions we already have and also answer other questions that come in the live stream.
Cool.
Okay.
Should I get started?
Yeah, I guess we'll just
okay.
We
so
just get started.
Yeah, so I have a list of questions that people have sent in. Some of these are worded weird, so I have to rephrase some of them. But yeah, I guess here it goes.
Oh yeah, and also I'm gonna hold next to. I'm gonna put up the old longboard here and like one of the first version SuperLongBoards here, just for you guys' interest. There it is.
All right, you ready for your first question?
I'm ready.
All right. Okay. Does the new SLB have any onboard provisions for changing step rates and current settings for users having stepper motors other than the long mill? If it does, are they accessed through software or firmware on the board?
Yeah, so I think this was a question that I answered in a comment on one of the YouTube update videos. And yes, basically what they're asking is, because the SuperLongBoard has built-in stepper motor drivers, and like because the drivers are built on, they're like wondering if the current settings and the micro stepping settings and stuff like that can be changed, or if they're fixed. But all of those values, we've made them accessible through the machine EEPROM. If you guys are familiar with our existing machines or Gerbil machines, you can kind of go in and list all of these values and then change them on the fly for your machine. And we've made new settings so that you can access the stepper motor drivers individually and change the microstepping and the current and the holding current and what else? Like the homing speeds and the travel speeds and the acceleration and like all that other stuff. Yeah. So yeah, it's all on there. And that makes it like the best use case for open source applications or like DIY CNCs or anything like that. Because obviously we're going to ship the boards by default flashed for the Mark II, because that's our most up-to-date machine. But then like if anyone has any different setup, they can kind of configure it for their own setup.
Cool. Yeah. Next question. Once we pre-order and receive the new SLB, will the new improved version you talk about be only a software update and or a hardware upgrade? And if so, how will this be handled?
Oh yeah. Yeah, so I think I've mentioned in some of the past videos that the SLB can do certain things now. And like there's a list, which we're kind of, I think you can find it on the pre-order page. It's like a list of things we're gonna guarantee will be available at launch when we start shipping the first batch of boards out. And then there's some other stuff on the board that for like reducing the initial complexity and reducing the amount of testing and stuff that we have to do, it's gonna be, like it can be potentially introduced in the future as future features. And so basically, as far as those are concerned, if we get them working, it would be as simple as just updating the firmware on the board. So if you guys are familiar with like GSender, how we have like a firmware flashing tool on there, and you can just go in and flash the firmware, it's as simple as just doing that, but with the new firmware file that we would make available for people to download. It's not like over the internet or anything, so you can do it in whatever situation you need. And then I think like some other people have heard us talking about this was like the version 1 SLB, which was able to plug in the compute module in the back so that it could, the idea was for it to run GSender on the board so that you wouldn't need your own standalone computer. But then for, in order to kind of keep things moving along and sort of in the board development so that we can get things out in a reasonable time frame. And because we were running into some issues, we dropped the support for that so that we could maintain all the other great stuff about the SLB and then kind of come back around to it later. And I think some people are kind of wondering about what that might look like in the future, because I think people do like the ability to run GSender standalone. So that actually is, well, you can talk about your stuff, but basically like we were originally going to try to run it on a compute module. And then what we realized is if we actually wanted to have higher processing power to be able to run larger files and do some other stuff with it, it might actually make sense to also, and the solution is also technically fully backwards compatible, is to actually have a built-in touchscreen computer setup or like fanless PC sort of setup that we can kind of like pre-set up to run GSender and everything, and then distribute it when people buy their machines. Yeah, you can talk some more about it.
Sure. Maybe I should add that the flashing, you can do it all in GSender, right?
Yes.
Yeah, so it's like get the file. Well, you have the files in GSender when you like download it, right?
Yeah, I think we could have the files in GSender, yeah, in the future. So it's like if you download the newest version of GSender and then you flash it, that'll be the newest version of firmware for the board.
Yeah.
But then I think we might also like distribute the raw files so that people can like change to whatever version firmware they want.
Cool. Well, that's a great segue into the next question, which is, when will the new improved version of SLB be released, and when will the new improved version of SLB be released where there will be no need for a computer next to the Mark II? Will this be a software update? So I guess to answer that question, yeah, so as Chris decided when we were doing the development, we figured it would be easier to build a computer separate from the controller. And I call it like a Wizard of Oz, like wizard behind the curtain sort of situation, where it's like you can have the board and the computer on the same board, but if you put a curtain and you have a computer and a board separate, and it's behind a curtain, you wouldn't really know the difference. Well, you wouldn't know the difference at all. It's basically the same thing. You just have a cable going between the two. And because the complexity of having a board integrated directly on the board and having it separate is like a different amount of work. It's a lot more work to integrate it directly because of all the pinouts and then the lack of flexibility.
Yeah, like once it's integrated, like if we choose something for you guys and we integrate it, and in the future we want to put something like even cooler on the board, then essentially we're now like forcing you guys to have to upgrade to a whole different board versus just changing out like the processing that's running the sender.
Exactly. So in essence, it's like the same to have a computer separate as it is together. So that's like one important thing. But it means that we can improve both without having to change the other. So that's like the pro. So yeah, I guess like a quick kind of recap of everything that's happened around the whole computer thing is that it is a very popular thing that people want. I think most people who answered the survey at the beginning of the development said, I want a computer on the longboard. And we believe that it's also a really important part to kind of streamline the CNC process because with so many different computers out there, one of the pain points is that everyone's issue might be a little bit different depending on the computer. Maybe you might have an unreliable USB port on the computer, or maybe the software configuration might be different, or maybe you're using a different operating system, Mac versus Windows. Even the performance of the computer might make a difference in terms of how GSender runs. So by basically like giving one option, like that was one of the motivations to have for the machine. Like just having one option means like we can control the process of actually like people using the machine.
Yeah, we can better support and troubleshoot it and stuff like that.
Yeah, and then secondarily, there's like a cost factor. If we can provide a computer that's less expensive than the other option you would have to use to plug it in, say a laptop, for example, we could save the user costs as well. And also, because people are using their computers in a place where it's very dusty, having a less expensive computer that's specifically designed to run GSender and the control software would probably be better. So that's sort of the logic. Obviously, you can still use the SLB with the computer, and in essence, it will be the same system. It just we're replacing the computer part. So if you don't have to buy the computer in a way. So I guess like in terms of people waiting for the computer, if the computer that you already have works, you don't really need to buy another computer. But for new users who are getting into it, they don't really have a computer they can use, then having a computer option makes sense. I think there's also a part of like the fact that the computers that we're looking at aren't very expensive. So people may choose to just get it to make their whole system consistent with everyone else's. But yeah, that's the background story. So over the last
time frame.
Pardon?
There's a time frame as well.
Time frame for what?
When that might be.
When it'll be available.
Yeah.
Yeah. So I actually just sent Chris a message this morning because I kind of worked through what I feel like would be the best way to approach this thing. And I've been working on different doing research on computers and different boards that we can use for the machine. And so one of the main things is that initially we were planning to use some sort of Raspberry Pi, like a compute module for the board. but because the computing power of it was not powerful enough, it wouldn't leave enough headroom. We could probably get it to work with G-Sender and like optimize it so it would work on that chip, but
we spent a couple months trying to like squeeze the most that we could out of it to get it to work the way we wanted it to. So we're not trying to give you guys half-baked solutions, right? Like we're not trying to sell you guys something and then be like, oh, you know that board we came out with last year? Yeah, we realized it wasn't good enough, so now we're coming out with a new board this year or whatever. Like we're trying to give you something that's worthwhile and it'll last.
Mm-hmm. Yeah, so the Raspberry Pi is not powerful enough, so we kind of, well, essentially, if you want to add something else in the future, maybe G-Sender gets a new feature, we want to add webcam, whatever it may be, you wouldn't squeeze more out of the Raspberry Pi. So that was sort of, booted. We looked at some of the other compute modules, like the Pine 64, I think, and
what was it? Latte Panda, but that's kind of like more of an onboard computer at that point.
Latte Panda was also a good option, except it was really expensive, and we needed to build like a whole case around it. So
there's a couple other like Pi duplicate boards, like the Big Tree Tech board and the Banana Pi. I think there's like an orange Pi. I don't know.
Just like a whole bunch of like Risk V type of boards and stuff. But what I kind of ended up, so what I found out, so I bought if you guys go on Amazon, there's a computer called a B-Link. They're about like $200-ish. I bought one on sale for like $130, which is a really good price. And it runs full Windows 11. And you can plug a monitor, keyboard. It's got the Wi-Fi, Bluetooth. It's basically a full-fledged Windows computer on like a box about this size. So I tried that out. I tested it. And I also got the touchscreen. So you've probably seen maybe some pictures that I put on Instagram, just like as a teaser, where we had, I had the touchscreen running. You can like run G-Sender and stuff through the touchscreen, and I tested a little bit on the Arduino and all that sort of stuff. So basically, we can buy that computer for about $90 US, like straight from the company, and we can get them to pre-configure it with the G-Sender and have it work as a server, so you can send files to it, and it seems to run really smoothly. It's super quiet. It's like pretty much a one and done solution. And the only kind of like caveat is there's 1,000 computer MOQ, which is kind of a lot. So I think at this point, there's a couple of next steps if we want to go down that route, which is making sure we have the money to buy so many computers and having people who want to buy them, and then having the configuration and the setup and the cabling and all that sort of stuff to work directly with the SLB. So I think comparing to like some of the other options, like the Raspberry Pi and some of the other computer modules and all that sort of stuff, that price point is pretty affordable. I think once we get it
for
out,
the package.
Once we get it out to customers, we'll probably have to sell it for around $200, I'd say.
Yeah, probably.
It depends on what it comes with and how many people actually want to buy it, because it really just comes down to the most complicated part is going to be like, how can we buy so many computers without like being able to have the cash flow for it, essentially. In a way. So but yeah, we have the SLB, sorry, not the SLB, that computer. I've been putting together the alt mill so I can run it using that computer, and I have some projects in mind for it. So I'll be able to test that out, and so far all the testing is working well. So just to answer the question, I think we found a solution that would work for the SLB and just in general. And that computer can work with the original board. It's just a computer.
Yeah, with the long board, and theoretically it can work with other control boards, like Gerbil-based control boards as well.
Yeah. So I guess the big question is who wants it. If you guys want it, send us a message or leave a comment or let us know. I think for us to break even on buying 1,000 computers, we would have to sell about 500. So we'll see how we do.
So we'll be
this.
looking in the comments of this video for 500 comments.
Yeah, we
saying
need
that
500 people being like, I want to get a separate computer for the SLB, and then we can go forward with it.
Yeah.
So.
And I think like roughly the timeline would be like if it were to happen after all the testing and stuff, it'd probably be like middle of next year.
No, I think it could be a lot sooner. So the actual site like turnout, I guess like the place an order for them and getting them here will be about 2.5 months.
Mm-hmm.
So if magically we have like 500 people lined up being like, we'll give you some money to buy the computer as well, it could be like probably like 3 months from now we could actually get them to people. But you know, ordering them is the easy part. We need to make we would have to make the configuration.
Yeah,
and we would have to set make sure it works so that you get them out of the box and they're ready to go. So that's kind of the hard part.
Okay.
And, yeah. So
I'm gonna call out some people to say welcome.
Okay.
In the chat. So we got people from Ottawa. Good to see you guys. We got people from, I think I saw North Carolina in there. So that's pretty cool. Hello, guys from Ontario. Who else do we got? Florida. Good to see you guys from Florida. Let's see. We got some people from Alberta. We've got, let's see. Yeah, I can answer some of the chat questions.
Sure.
Yeah.
Look, we
so
have
that we don't lose
55
them.
more 55 boards.
Oh, we're at 55 orders.
Yay.
Thank you, guys. I'm glad you're liking the stuff. And I'm going to answer more of your questions as soon as we can. Let's see. Was there anyone else? Quebec, Victoria, Pennsylvania, Newfoundland, Vancouver Island, Oregon, Kansas, Lehigh Valley, Pennsylvania, Minnesota, Wales in the UK. Wow. Hi, all of you guys. It's great to have you all showing up. Great to see the interest in the SLB. We're really hoping that what we're doing with the board, you know, as you guys know, it's going to be an open source design. And so we're really like, I think I've talked about it in the past update videos. Like we've kind of, we're trying to be the people where it's like open source inherently is like hard to support. Like if you look at other open source companies, they put a whole bunch of time into the R&D and into the development and the testing and all that other stuff to make like a final product. And once it's released, then anyone can kind of like take that and build on top of that. And we're so lucky that there have been people who have done that before us, who have made amazing open source projects like Gerbil Hal by Terrier. He's an amazing fellow. I've talked to him quite a few times. The original Gerbil boards, the CNC control boards, the drivers, and all that other stuff that we've been able to build on top of. And what we're really trying to do with the SLB, the SuperLongBoard, because I realize I haven't called it by its elongated name, the SuperLongBoard, is the same thing. We've put, probably by the end of this whole operation, we will put probably like $300,000 to $400,000 of R&D and people's time and testing and all that stuff into making this board that we're then going to be making available for like people to have access to the open source designs. And I'm really hoping that this is going to be a big thing for pushing the hobby CNC industry forward, exposing Gerbil Hal to everybody and pushing more machines to be able to use Gerbil Hal and Gerbil Hal based board designs, getting inspiration from the design that we've implemented if it ends up being as successful as I'm hoping it will be. And this is like something that, to be honest, as a company, we've been looking forward to being able to do basically since we started the company. We've always wanted to be out here to be able to make our mark on bringing the accessible CNC machines to the hobby CNC community. And I'm really excited about what this board is going to have to offer already, like the stuff we've been doing already. The beta testers are really enjoying it. And also what it could have make available in the future for controlling machines and making machines that are easier to use and provide better feedback to the user and stuff like that. So anyway, I'm going to answer a question higher up.
I have some questions that I can pull on the screen so you can.
Okay, sure.
I select some.
You want to grab like a higher up one?
Yeah, I'm going to.
Okay. Oh, I don't have that open. Do you have the one on the screen? Oh, it's on here. Oh, I see.
It's like so meta.
I'm watching, by the way, I'm watching the live stream on my phone and then I'm looking at the questions on
You
here.
can point your phone at the camera and then you'll have
And
to
then
input a
you
loop.
guys would see. Yeah. In your video, you said that true 4-axis cutting will be accommodated. No. So true 4-axis cutting, it will be accommodated at the time that we launch the board. It's just this plug. If you want, you can switch the camera view so people can see. Is it switch?
Yeah.
Okay. It's just this plug here. That's the 4th-axis driver output. Oh yeah, you might have to make it bigger for a sec. Nice. You just have to, it's this plug here, and this is the 4th-axis limit switch here. And then you can't see it here, but it's going to an external driver down here. But I think you guys have seen it. Idea on that. But yeah, it can, like, we've already done testing on 4th-axis stuff. We're going to keep doing testing on 4th-axis stuff. The entire idea, or one of the main ideas behind the board, was giving us more axes to work with so we can more fully support the Vortex rotary axis that we put out earlier this year, and any other like rotary axis someone might want to run. We kind of took a while to get on board with the whole rotary / 4th-axis cutting because it's still hard to find software that supports it. And even true 4th-axis cutting, the test that we showed in the update video is kind of janky to set it up, if I'm honest, because it's just like a lot of the software that can generate the toolpath files to actually generate true 4th-axis cutting. Some of it is like cheaper, but it's kind of janky. And then the rest of it is just like super expensive and kind of tricky to learn how to set up and stuff like that. And even accommodating rotary axis on the regular longboard. If you guys haven't seen, we made lots of resources about it. We wanted to make sure when we came out with a product that it came with a lot of tutorials and guidance on how to actually use it, because it's very hard. And like, it's hard to, I like to use the phrase, wrap your head around because it's a rotary axis. But it's really hard to wrap your head around and get it working right. And so the 4th-axis, like full 4th-axis cutting, will be available on the board. It's already tested, it's already implemented, and it's like looking good. And it'll just be a matter of plugging in an external motor driver to run your 4th-axis. And then also, like, we're gonna try our best between now and the time of launch to see if we can make some documentation on how to set up the software side of things. But it's like, our hands are a little bit tied. Like, we don't have the bandwidth to make the software from scratch, so it'll just be whatever exists out there. And that part we might have to leave up to you guys. So if you're interested in doing full 4th-axis cutting, you should probably start doing your research now, because whatever you find out there is what we're gonna find out there, basically. And if you're just planning to use the 4th-axis output so that you can use the Vortex without having to switch between the Y and the A axis, like just an easier setup and takedown sort of situation, then in that case, it's the same process as the existing Vortex, process when you set it up and run it and stuff like that. But you're not having to switch between the two motor outputs. And you can, because it's true 4th-axis control, you can basically just hold the Y axis in place while you do the rotary cutting.
It'll make the zeroing and the alignment a lot faster and easier too, right?
Yeah, exactly. It looks like the board is less long than the old one. Can you explain? Thank you for the question, Mr. Kevin. If you guys don't know Kevin, I don't want to like super out him, but he's someone on our team actually. But yeah, if I hold up the old longboard against the new SuperLongBoard, that's probably true. But yeah, what actually happened there is you can see the old motor drivers we were using here, they kind of inherently take up quite a bit of
It's not about the length of the board. It's a never mind.
yeah. Yeah, okay. What's the next question? Anything else required to fit the SuperLongBoard on a Mark 1? No. To be honest, like, we'll switch back to the board view for a sec. So you see these plugs. Okay, I think the audio is working. If you guys want, you can write a comment to say that the audio is working. Our little audio processor box, I think, ran out of batteries.
Kevin says anytime you're on board only view in OBS, there's no mic audio. Need to stay on split or add the audio to the scene.
Oh, that's not handy. Is it working now?
Yeah.
Sorry about the delay, guys. So just to answer the question, transferring from the, so if you've got a Mark 1 or a Mark 2 or like any long mill that we've sold, your board will look basically like this. This is the existing longboard that we sell. And if you want to transfer for all of your existing plugs from your Mark 1 or Mark 2 long mill to the SuperLongBoard, it's as easy as like, I just pulled out the X-axis plug here, and you can see that it just fits directly onto here. So this would be your wiring setup. You just like unplug that plug and plug it in here, just like that. Also, if you've got limit switches, they would be in these plugs here. You just take that out and you plug it in here. It's like literally the exact same plug, just like that. And yeah, it's everything. We made it fully backwards compatible. I don't think there's anything you guys will have to worry about. I think the only ones that change slightly is if you were using the spindle outputs or the limit switch outputs. The plugs are slightly different, but all of our plugs still use these terminal connector blocks, which means that anytime you have to change the wiring on any of this stuff, you just unscrew the flathead on the top, you switch the wiring over to the new connector, and you tighten it back down, and you're good to go. And then you just plug it in. It's as easy as that. Okay. I think that answers that question.
Do you need more questions?
I think they probably have a bunch more.
Yeah.
Okay, well.
We'll probably answer those ones too.
I was so prepared.
You're a good host. You're a good host.
Thank you, thank you.
Do I see the question? Yes, I do. Will updates to the board be available to all of us ordering early if hardware, software changes are made between pre-order and final production? So One thing I just want to make clear is that even though you guys are ordering early and you're getting a slightly different price, the boards that are becoming available for like launch will all still be like if you were to order a board the last day of January and then you ordered it, and then someone else ordered one on the first day of February, they're all still in line for like the same like
Manufacturing run.
yeah run of boards that we're doing that we're going to be planning to ship out in March. So I think so there won't be any like hardware changes made to the board. Like we basically we're getting another batch of prototypes in, and once they arrive, we're going to check them, and if they're good to go, like that's how the board is going to be for the next while. Like we've made it kind of set up to do those things, and any like firmware update will be like we're planning to kind of validate any of the way that the firmware behaves with the third round of beta testing that we're going to be starting before Christmas. And so any updates that come to the firmware, we're going to be making those like to the boards before they ever ship out. So I think I've answered your question. I don't think that it's anything you'll have to worry about, Chuck. Question answered. From Gary, can I assume that with the SLB now, it will allow installation of a spindle ASAP? What about the previous weight restriction issue? Those are two really good questions. So installing a spindle, I think I talked about it in one of the update videos, but we have now two options for spindle outputs and a third independent laser output. So for the two spindle outputs, one will be 5-volt PWM, similar to what the previous longboard offered. And then the other one will be RS-45, which means that you can have like more communication happening between the SuperLongBoard and the VFD. And you can get more intricate control of it rather than a simple 5-volt PWM signal. So yes, installing a spindle, if it's on our list of verified like RS-45 spindles, then as long as you are like have your manufacturer's manual and you've set it up correctly, because there's some settings that VFDs have that you have to set up, then you just select the setting on the SLB for that VFD and you should be good to go. Or if it's a 5-volt output, then you just use the 5-volt PWM output. You want to say something?
Yeah. Are you done?
I was going to talk about the weight restriction, but before I go to that.
Yeah. So the other so this is another hotly debated topic about which outputs to use for the SLB, because me and Johan have been working on the CNC router project, and so background, Makita is good, but it's like could be better. We're like we should build a better version of it, and we went down this rabbit hole because we want to add speed control to the router essentially.
Yeah, and on and off.
Yeah, and on and off. So there's three like main common control methods. There's 0 to 10 volt analog, there's 0 to 5 volt PWM, and then there's RS-45. So we can technically do all three, but it's sort of like, do we want everyone to pay for all three when, people aren't going to use all of them essentially? So we did a survey to ask people like, which system do you use already? And you know what the most common way people control the speed of their spindle?
They yell at it.
Almost. They basically don't. Like you just turn, like the most common is just turn it on and off. And then the next common is like using the potentiometer that's built into the VFD to control the speed. So in essence, in practice, a lot of people don't actually really control the spindle either through their controller, and if they do control it, they're doing it manually, which is kind of interesting. From what we can understand, most VFDs, they'll either use 0 to 10 volt analog or RS-45. RS-45 being a little more complicated to set up, and 0 to 10 volt analog is more simple, but has some, I guess, like lack of functionality there.
Yeah.
And then 0 to 5 volt PWM is the most common output method for most hobbyist controllers. And so we were like kind of stuck on picking one or the other. So in essence, we picked RS-45 because that would give us like all the functionality that we would want. But the reason we picked 0 to 5 volt PWM is because you can get a separate board that'll turn 0 to 5 volt PWM to a 0 to 10 volt analog. So 0 to 10 volt analog is a lot more simple to set up on most spindles. So if you don't end up wanting to like use RS-45, what I would recommend, and we probably have an option for this down the line, is to get a 0 to 5 volt PWM signal to 0 to 10 volt analog board separate, which costs a couple dollars, and then use that for your spindle. But what we suspect, once we have the router available, is that most people the router is like the best of both worlds in terms of spindle and the router, where it's like, it's compact and super easy to set up, but powerful and quiet as like a spindle would be. So the plan for the router is to have a 0 to 5 volt PWM input because it is the most commonly supported on hobbyist boards. So not only can you use it on the long mill, we suspect it'll kind of be the de facto in terms of any controller. So as far as our research, almost all controllers use 0 to 5 volt PWM, especially if they're on the Gerbil firmware, channel.
Yeah.
Because that's like what it natively uses, especially with the integrated circuit. So
Yeah, just to give you guys some background, if you don't know what Andy's talking about, we're actively working on a new project here at the company where we're making our own spindle router sort of hybrid, you could call it, that we want to make available to the hobby CNC industry. We've got blog posts about it. We've got surveys about it. If you want to leave a comment or check it out or give us feedback about it, we'd love to hear. But yeah, as he was explaining, we're kind of we've realized that a lot of people pick up spindles for specific reasons. But when you're buying a spindle, there's actually a lot of other functionality and features that you're paying for that most people are never using because they don't need it. Like if you're in the hobby sphere, you don't need to do like super advanced stuff with it. But when you're buying a spindle, you're actually paying for all of those advanced features. And so what we're actually looking to do is we're trying to take marry the lower cost of a router and the much higher cost of a VFD and find a way to pare it down and also make it like kind of pre-programmed so that on any given like hobby CNC router machine, you can kind of plug this in and then it'll run like the on off and the speed control much more easily for you. And so that sort of use case is what the SuperLongBoard is already going to be able to support, as Andy was talking about. And also just to answer the other question about the spindle weight restriction, realistically, the reason we gave that weight restriction is because when you've got a much heavier spindle on here, it does load the motor more, but also if you have the power to the stepper motors disabled, it can start to lower over time. Now, one of the cool things about the SuperLongBoard that the existing longboard didn't have is that if you wanted to hold the motors, you had to hold all of them at the same time, and you had to hold them at basically full current. So that means the motors would get really hot, the drivers would get really hot, and some people did it, but they would have to run like a fan over the heat sinks for the drivers and stuff like that over these guys. The cool thing that we've done for the SLB, this is part of it is inherent to Gerbil HAL, which is the ability to hold stepper motors independently from each other. And so basically, if you're running a more heavy spindle, you can hold the Z-axis motor only and keep the rest of them not holding. So then you're only turning this one on because you need it on. And the second thing is that we've implemented like a reduced holding current with the motor drivers that we have through the Gerbil HAL plugin that we've worked on. So that basically allows the motors to use just a percentage of their full current. We found like around 35% is a good amount so that it just holds everything there and it won't ever move. and it's not running the driver at like 100%, so it doesn't overheat or anything like that. Oh, and the other thing I was going to mention is the reason why the 0 to 5 volt PWM is so ubiquitous, yeah, is because a lot of the hobby machines, whether people know it or they don't know it, almost any hobby machine that you find on the market is typically Gerbil based. And because they're Gerbil based, it means they're Arduino Uno based. And because they're Arduino Uno based, that means that the electronics were designed to work off 5 volts. So that's why basically if you want like the most simple PWM output or just output in general, it's the easiest to just put a 5 volt PWM output. That's why a lot of boards have them currently. And I think like we kind of have one of two options when we're moving forward. On the new SLB, we're actually using the STM32F412 chip, which means it runs off 3.3 volts, not 5 volts. So like we could have moved to 3.3 volts if we wanted to. We could have, like the input voltage is 24 volts, so we could have made all the inputs and outputs be at like 24 volts, 12 volts, 10 volts. But I think we've kind of made the decision to opt for backwards compatibility and compatibility with what other boards have in the past. And you know, there's nothing really wrong with 5 volt PWM, so that's what we decided we would stick with. And as Andy mentioned, you can kind of make a breakout board that converts that to 0 to 10 volt analog. Gagilliams 14. Will the cable be available to attach the 4th axis driver to the SLB? Yeah, we could probably make that available. Yeah, it's a very standard cable, so I don't see why not.
It's just a 4-pin, right?
He's talking about the 8-pin one for the 4th axis output.
Oh, okay.
Yeah.
Sure.
Yeah, it's a pretty standard one. Another question. It's gonna update in a second for me.
Will there be a case surrounding the SLB?
Oh yeah, the case. Yeah, so in all the videos and stuff that I've shown you guys, oh, you can see it on there. I see.
I can see the feature.
You've seen I've shown you guys like the 3D printed version, and I realized I forgot this in all the other update videos to tell you that the final case is actually an aluminum extrusion that we've designed. This longer part here. I think they can still see it. Yeah, this like longer part here. That's audio. Okay, that's the extrusion that we're going to be designing. We don't actually have a sample in right now, so I can't show it to you. In this version, it's 3D printed, but that whole part is an aluminum extrusion we designed. And then these end pieces here are also going to be made out of metal, and they're just folded and screwed in from the side. And they're going to be laser engraved with the plug outputs on them. And then there's an acrylic front part that goes over, and it's frosted acrylic that will help distribute light. I think I did show the frosted acrylic example in the last update video. But when you're paying for the pre-order right now, that is coming with the whole enclosure. And we don't have an e-stop to show you guys because I just didn't get around to 3D printing like the current version, like design version that we have. But it's like an e-stop with 3 macro, like programmable, customizable macro buttons on it. And that also comes with that cost. The only thing that doesn't come with the cost that you're paying with the board is the power supply right now. And so the idea would be like, if you guys already have a long mill, it's likely that the power supply that you got, if you have a Mark II, the power supply that you got, you can just plug it straight into the SuperLongBoard and you're good to go. If you're getting it from a different machine, then you'd probably have to like look at the specs. Usually the power supplies we use are 24 volt output, and the one we use on the Mark II is a 12.5 amp output. And the older Mark I's, some of them had a 10 amp output. There have been some questions about if we can support that. It is likely that we can, because like if you add up the current usage of all the drivers, 10 amps should be enough. But we haven't done extensive testing with that. We've done all the testing on the 12.5 amp output. So, but the good news is that you guys don't have to like rush to buy a power supply or think about the power supply usage right now. Like, we can make sure to get you that information at a later date. And if it turns out that you realize you need one, you can also place an order for the power supply, and we can bundle it together with your SLB when they start shipping.
I think when I did the testing with the current meters, they were like, you weren't using more than 7 amps under
Yeah.
regular. So I think the 10 amp will be fine. But
yeah.
like statistically though, the 12.5 amp, the specific power supply has been like almost like almost flawless in terms of defect rate.
Yeah.
Because so that's like another story I can tell.
Well, and also ideally, you don't want to be using the full current usage on a power supply. Otherwise, you're going to strain it a little bit. So the 12.5 gives it a little bit more headroom.
Well,
if you want to get into the story, maybe we could do it after.
Yeah.
So that I can answer questions.
I'm like, based on my knowledge of when I did the sourcing for the power supplies, both the 10 and the 12 will both be fine. But the 12 is like mechanically more better because it's more reliable as a power supply. So it's like a good upgrade if that's important.
Yeah. So I hope that answers that question. Will the SLB require a fan? No. One of the things that we've done is we've tried to make sure we overspec everything, even the TMC 2660 drivers. If you look around, like the trinamic drivers are used on a lot of different boards, but these drivers in particular tend to not be used because they can handle a lot higher current, but they're more expensive. But we chose them because we wanted to make sure that we had lots of headroom when you're driving the motors around. So like we've run the board for like long tests and stuff like that, and the drivers don't really get hot. So we don't even have to put a heatsink on them, and they work just fine. So you don't need a fan.
But we need you guys, our fans of the SLB. So stick around for more content.
Exactly. Did you, by the way, is one of the questions from Woodcutter?
We have a Dennis Huddleston.
Okay. I'll answer the Woodcutter question quickly because it was near the top, but maybe it got missed. Woodcutter was asking if anyone knows it's possible to put the longboard on a Shapeoko Pro XXL. I can't give you an exact answer for that, but I think one of the things that people kind of get tripped up on when they're looking at control boards is like, they're like, oh, it's a completely different machine, so how is it going to work with the board? Realistically, it all mostly comes down to just the stepper motors that you're using. Like if I'm not super familiar with the Pro XXL, but if it's using like NEMA 23 stepper motors that are like kind of similarly spec to our machine, then
they are like, I think when we did our research, they're almost exactly the same.
Yeah.
So
then
you'd be fine.
You're basically already good to go. And the same with like limit switches. Like we designed our board so that it works with like all common forms of limit switch inputs. You can use powered ones, unpowered ones, normally closed, normally open, and it uses terminal blocks. So you don't even have to buy crimping tools or anything. Like we designed this board so that it's like really easily swappable to other setups. So I feel pretty confident that like most machines it will work with. Like one of our beta testers uses a Onefinity and it's working on that just fine. So like I don't think there will be many instances where you'll run into problems, except for as I brought up in the past, like closed loop motors or like ones where you want external stepper motor drivers aren't currently going to be supported. And I'll get into talking about an idea that we have for that in the future, but this board won't support it. It might be a modified version of the board that we release in the future. So if your machine has separate stepper motor drivers or like crazy stepper motors or closed loop stepper motors or something like that, then we can't support that. But I would say any typical hobby CNC machine setup that's like a sub maybe like $3,000 or around like the $3,000 range, it probably is running electronics that we support out of the box.
Yeah.
I would say in most cases.
Yeah, basically.
Yeah. Okay. From Dennis, if I purchase a Mark II long mill now, will the longboard be installed in it? Okay, I think maybe you're asking if the SuperLongBoard will be installed in the SLB. Currently, the longboard is the de facto board we've been using for the last like three years, I think.
Roughly, yeah.
For the long mill. So if you bought a long mill right now, it will come with this. The SuperLongBoard won't be in production and available for like, it won't be being distributed until March of next year. So you got a couple months to wait. But what we've tried doing, I think I explained this in the last update video, and Andy explained it in the blog update too, I think, is when we do switch over to shipping the SLB as default with the machines, the price of the machines will be increasing. And so in my opinion, it creates a scenario where it's like, you can probably just buy a long mill now, get used to it, play with the software. Like the longboard still works great as it is. We've been using it for 3 years. So it's a really good option. But basically, you can still also put in the pre-order for the SLB, and it would cost actually maybe a little less than if you had waited and bought the machine with the SLB included. And then, so you can buy the machine now, you can pre-order now, you can get used to the machine, and then when the SLB starts shipping, it'll arrive at your house and you can swap it out, and now you can keep going and have even more functionality. So that's how I would answer that question.
Is it Windows 8 compatible?
Yes. Like the board is running Gerbil HAL. The SLB is running Gerbil HAL, which is just, you connect over USB. So any CNC control software that works with Gerbil HAL, like our own control software GSender, as long as your computer can run GSender, then GSender can run files to the board, and GSender can run on Windows 8. So you're good to go.
Next question, we have Gerard Cochran.
Hello, Gerard.
Will there need to be a firmware update? If so, how will it be done?
Yeah, I think that's similar to a question I answered earlier, where if there's ever any firmware updates, we have a tool that we're building into GSender to handle that. You can also use like other tools that work for the chip that we have on the board, so you don't have to be locked into our own software, but we're just making it so that the easiest way to update it is through GSender. And yeah, it'll just be like a file that the newest version of GSender will have built into it already, so you can flash it right there. Or it'll be a file that we make available on our website, so you can download it, and then you put it on your computer, you put GSender on your computer, and then you say, GSender, put this file on my board, and then that will update the firmware. It's basically as easy as that.
David Sander says, what's a driver that we have to buy to run the rotary?
Oh yeah, so I don't have like an official guide on the external driver you can use to run the rotary right now. So far, we've been doing testing on the DM542 motor driver. Also, like the drivers we use on the existing longboard are like pretty decent, like they're okay quality. They're TB6600 drivers, and you can buy those standalone too for pretty cheap online.
Well, so like that's another.
Yeah.
Be very careful on the drivers you buy online, because a lot of them are fake. And I've done a lot of testing with like drivers you buy on Amazon and stuff for really cheap. Sometimes they lose steps, sometimes they're not good, sometimes they overheat. There are obviously good ones, and probably at some point we'll make a kit or like have some sort of recommendations people can use for it. But
I think in the long term, like in the next couple of months, we'll be looking at making sure that we have like an option for like we have our Vortex accessory, right? We'll have an option for all the cables and the external driver necessary to hook up, so that you can run it as a full 4th axis. And whatever driver we select for that will probably be available for purchase without the cables as well, if you have a different rotary axis setup that you can use.
But I guess for perspective, like the drivers aren't super expensive. If you want to buy it off the shelf, I think that you can get a good quality one for about $20.
Yeah.
And then it's all step driver enable. I don't know if everyone's familiar with it, but there's a protocol that you use for controlling it. So that's pretty standard.
Yeah, yeah. And our board is already set up to handle those outputs to all the common like stepper motor drivers.
Yeah.
Yeah.
Kenny Sweat asks, can I buy the y-axis of the alt mill? And my answer to that is yes, as long as you also buy the x-axis for it and the z-axis for it too. Well, okay, so I'll give you a serious answer. So right now the alt mill is in production, but like we make them in like sets. I think I guess a question that's really being answered is, can I take the y-axis of the alt mill and put it on a long mill potentially?
Yeah, maybe that's what they're asking.
Yeah,
I don't know.
but I would say no, because it's like too much work. So when we build our machines and when we do our products, we try to have all of the parts available independently for everything. So if you go on our website and you look up, I need a gantry plate, you can buy the gantry plate, or you can email us and we'll work out something to get you the parts that you need. And the reason we did that is because we want to make sure that customers are confident that if they've used their machine for 5 years, 10 years, 20 years, forever, you have the open source files and you have access to the parts to be able to make sure the machine keeps running. We will probably have parts available for the alt mill when we get into scale. Right now, we're only building 50 or so machines, so it's not a priority for us to provide parts to the wider audience because it's just, time management is difficult. But yeah, so that's kind of the answer.
Yeah, I think maybe we can keep answering the onboard questions for now. But I remember there was also a question of people asking if the SuperLongBoard will be used on the alt mill, which is like another thing we could get into maybe later.
Yeah, I mean, I can answer that whenever. Well, you can answer.
Actually,
we can both answer that.
Yeah. Actually, we can just answer it right now. Basically, so the testing for the electronics aspect of the alt mill is still underway. But basically, the way that the SuperLongBoard has been set up, we think it's going to be possible to basically, where the motor drivers, like the built-in motor drivers are on it, we might remove those and put plugs there instead so that it outputs like the step enable and direction signals to external motor drivers. That might be like a future version of the longboard or the SuperLongBoard that we put out, which I might call the SLB EXT for external driver support. This is all still like a work in progress, but what that would allow us, what that would allow us to do is to like output to the stepper drivers that we want to be able to use for the closed loop motors for the alt mill. So then also we can still use basically all the same firmware and stuff like that. It would be like a slightly different version of the firmware, but it would basically be the same as the one that the regular SLB would run. So then all of our machines could benefit from all the work we've been putting into the SLB. And the board might be a bit cheaper as well because it doesn't have the drivers on it. But anyway, I digress. I'll let you take over for how the electronic stuff is going for
alt mill.
Yeah, is there any stuff you want to talk about for that?
Not specifically. We can do we'll probably have a better update. Me and Daniel have been working on looking at different closed loop steppers. You sent me a recommendation that actually Daniel bought for another project. So we may test those.
Again?
Cool. Okay. Are we back?
Yeah.
I forgot where I was talking about.
Yeah, I'm just gonna say, guys, I'm sorry if I know this isn't the first live stream where we have problems. We're trying our best, but also we're CNC engineering people. We're not the best at all the camera and audio and stuff like that. So we hope you guys are okay to bear with us a little bit. I think you were talking about the closed loop stepper motor investigation.
So I guess really the conclusion we came to initially was we need closed loop motors to get the power and the speed we want out of the alt mill. And so Daniel's found, you sent me a suggestion I sent that suggestion to Daniel. Daniel's like, hey, I already have these motors for a different project. So we'll test those. I set up the alt mill with the original motors, and then I was going to ask you if there's an extra SLB to use on that, or just use the original ones.
Right.
So like no specific like details on the electronics for the alt mill yet. And then Daniel was working on the schematics for the kind of like the breakout board version of the SLB.
Right.
So what seems like the most easy / effective way to get all the features of SLB into alt mill is just to take the SLB and modify it for alt mill.
Yeah.
So I mean, we'll cross that bridge when we get there, but
Yeah, we will.
I think that's kind of the answer so far. Yeah.
Okay.
Yeah.
What was the question that was being waited on?
Will the new boards be able to handle higher wattage lasers?
We haven't been able to do like extensive testing with all of the diodes that are on the market. I think when it comes to higher wattage lasers, from my understanding, it mostly comes down to the laser driver board that they have, and not the signal that the laser driver board receives from the motor, like from the CNC control board. So I think if you look at the laser that you're thinking about supporting for your CNC, and you can check the specifications for it, it'll show what the input signal is that it looks for in order to be able to like modulate the power and turn on and off. And it's pretty likely that it'll support 5 volts on off and 5 volt PWM. And if it does that, then you're probably good to go.
It might be worth, like, so I did look through the settings you can use for Gerbil Hal for lasers too. And what's really interesting is that you can set the pulse speed, like the pulse frequency,
Yes.
to be like very, very high.
Yes.
Like high as,
I think it goes as high as like, I think Andrew said we could go it as high as like 50K
yeah,
hertz.
yeah, which is for like those like super expensive metal RF tube like CO2 laser things, which obviously you would never need for something like this.
Yeah.
But there's ways to help you answer the question. There's ways to adjust the pulse frequency and the settings in the board to work better with different diodes.
Yeah, yeah.
Right? So
yeah, like the Arduino output by default was for Gerbil was set to 1,000 hertz. And so by default, the SLB, that setting will be set to 1,000, but you can set it like to basically anything you want. It's like adjustable. And also like the minimum and the maximum voltage operate within a 5 volt range, but you can tweak them based on how you want your laser setup to be. You can change the duty cycle of the PWM frequency. Like there's a lot of features you have access to.
Yeah.
For compatibility.
Yeah. So I think the board is never going to be the bottleneck.
Yeah, yeah. I think unless your laser driver is like really weird and it needs like, I don't know, it needs like an amp of signal or something, but I don't think any of them work like that. No. So yeah.
All right, next question from Ron Schill. If the firmware is flashed for Mark II, does it need to be reflashed for Mark I, or does the firmware work for both?
I think the firmware should work for both, and then you just change the settings after the fact. We'll have like default machine settings. It's very similar to how the firmware works right now for the existing longboard. Every machine that we ship out of our doors right now is flashed with the exact same firmware. And then all you do when you receive it is you just change there's some settings you can change after the fact that doesn't require firmware flashing. And that makes it work for your specific machine. So that's the way we're probably going to have it set up for this new firmware on the new board. Yeah. So it'll be easy.
All right. Another question from Gerard is, will the new router / spindle be a good match for the faster speeds and rigidity of the alt mill with the SLB?
That's a good question for Andy.
So we don't know exactly sure yet. So there's a lot of like variables. So I think I wrote in the last update, Johan got the data from the test samples for the Makita itself. I think the max output power was like 400-ish watts. That's like at max efficiency. So even if you're pumping like 1,000 watts into it, you're only actually getting 400 watts of cutting power. The data from we haven't received the motors yet, actually got sent to the wrong place last week. So they had to send us a new one. But if we get a 500 watt motor running at 80 to 90% efficiency, like they'll match, even if you're only giving it 500 watts of power, you're gonna get the same amount of cutting power. So we have that coming in as a sample, and then we have another option that's 1,500 watt motor, which in theory would match like a regular 1.5 kilowatt spindle. So it depends on if we want to build the router specifically for just long mill type level users, or if we want the power to be enough for both alt mill and long mill. And also it depends on the characteristics of the motors themselves, because another thing that people might not know is that the VFDs and the spindles, they don't have closed loop speed control. They're basically like it uses the frequencies of the coils to adjust its speed, and you kind of like brute force the torque. Like as long as you don't go above the torque range, it kind of like brute forces it to spin at the right speed. So you might notice that in some cheaper routers, if you like run or like a drill or an angle grinder, you'll notice that when you like go into the material, it'll slow down. And what you want for a CNC machine is for the speed to not slow down, or slow down very, very slightly. Mm-hmm. And even for a VFD, because there's no closed loop, it can't adjust its power or speed to compensate for the cutting. Whereas a brushless DC with a closed loop system, or field orientation control, which is another control system, will be able to control the motor so that even if you're like running at a lower power, it'll be compensating the torque of the motor itself to give you the same amount of cutting ability at the bit. So what I'm hoping for is that a small motor will be able to cut as effectively as a big spindle, and then it can be used for both. But realistically, power is still power. So we may need to go up to a bigger motor to work for both. But I think in practice, or like once we get to that point, we'll have enough knowledge and understand how the process works so that we can either have two different routers or we'll be able to make that decision down the line. So you'll have to keep up to date. Mm-hmm. But
watch the blog.
Yeah. But the idea is to have the SLB and that router to be like plug and play compatible with each other. Mm-hmm. And that's why we're talking about the PWM stuff. So what kind of is lacking in the market right now is just making it easy for people to be able to control the speed directly on the computer. And another really important feature about the SLB is that once you hit the e-stop, it'll be able to kill the power to like the accessories that are plugged into it.
Yeah.
So right now with the original longboard, if you have a Makita and you set it up with the longboard, you press the e-stop, the machine will stop running because it's killing power to everything, but it doesn't stop the router. There are ways to set it up to do that, but it's a little more complicated. But in the case where we have with the SuperLongBoard and the new router, when you hit the button, it'll be set up so that it kills everything, which will make it a safer machine. And also the making it turn on and off automatically, there's definitely like extra precautions we can put into the machine so that, for example, if it detects it's hit a stop or it's stalling out or something's overheating, the whole machine can shut down without the intervention. So in theory, it'll be a lot safer.
Yeah.
Yeah.
I'm sure there's other I saw some questions. I'm not sure if you chose any of these, but I'll just answer in case one of them you didn't grab one of them. But I saw some questions about like mounting the SLB. So I think I covered this in the update video, but I'll just cover it again. The pre-order that you guys are putting in, I forgot to mention, it also comes with the little bracket and the bolts for attaching the SLB specifically to the Mark II Y-axis rail, like the way it's attached here. It's just like a pretty inexpensive bracket. And so anyone who's buying the SLB and doesn't have a Mark II, you won't use that bracket. You can use it for whatever you want. Put it in your bracket collection or something like that. Yeah, so anyone that has a Mark II, it's just as easy as basically like the board will arrive pre-assembled in an enclosure, and then you just put the bracket on and you bolt it onto the rail, and then you plug all your plugs in and you're good to go. And basically for anyone who doesn't have a Mark II, like let's say you have a Mark I or another CNC machine, the design has these two flanges on both sides with 4 holes total that you can use just like regular wood screws or like machine screws or whatever you want to mount it to any surface you want. It can be the side of your table, the underside of your table, wherever you want to put it, like the outside of your enclosure or anything like that. So it's got a kind of like a global mounting method, which is just screws into any surface. And it's got the specialized method just for the Mark II for side mounting. And this is something that we wanted to try out because we feel like some people might be able to benefit from like having a designated spot to put the board, and then kind of the wire management might be a bit easier because of that too. And we're gonna just see when we put the SLB out there, how many people go for this option versus mounting it somewhere out of the way or what have you. And then that can help us in the future. It's not something we've ever tried before. We've always had, like the existing longboard came in a large enclosure. Actually, there's one right here. Like this. So the only option was to mount it like separately somewhere else with 8 screw options. So this is our first time experimenting with putting it on the actual machine, and we'll see how that goes.
I think one of the benefits of doing this is you don't need to make the cable so long, right? Because a lot of people put it on the left.
Yeah.
Yeah, so
it saves a lot of foot space, and it keeps the electronics like connected to the rest of the machine if you ever want to move stuff around. It technically is symmetrical, so you can put it on the other side, but the plugs will all be facing the opposite directions. So if anyone set up their stuff to be on the right side of the machine, they can still probably get away with that. It'll just be a bit weird. And yeah, and all the plugs are facing in the direction that we think will be beneficial. So they all go out just 2 sides. Our current longboard, they had technically plugs coming out 4 sides, or no, yeah, 4 sides, because we had the main plugs coming out the right side. The USB input was coming out the left side, the power coming in the back side, and the e-stop coming in the top side. But with the new SLB design, it's only 2 sides, where we've got plugs that come in from the front for the e-stop, the probe, the USB port, and some other future plugs we might plan to support. And then out the backside is where all the rest of the plugs come out. Some of them you plug them in directly, and some of them you take the cover off and they go through the cabling channels that are on the end here. So then you route them all out the backside there. Yeah. Okay, we can go to the question now.
all right, we have another question from Guy Gilmond.
Guy Hammond.
Oh,
Is that Guy?
I guess it's Guy.
Oh, cool.
Will there be an option for an LCD display?
No, there's no option for that. I was thinking about it for a while. It may, one of the things that I don't want to keep promising, but like we do have spare inputs and outputs on the board, like on the MC that we're not using right now. So that does mean that like there's flexibility for stuff in the future. It is something that I have thought about before of like having a built-in LCD screen, but yeah, I'm not going to make any.
Yeah, but you should
promises.
check out the pendant mode on G-Sender, which
Oh yeah, definitely.
lets you see what's going on, but wirelessly on your phone or whatever. Yeah,
And he makes
there's
a good
video
point.
out for that, I think.
Yeah.
Yeah.
Yeah, if you've ever wanted to see stuff happening about your machine in a more condensed display, if you set up if you can download our G-Center software and run it on any Gerbil-based machine. But once you have it set up, there's a remote mode as what we call it. And basically, if you go and you turn that on, we have documentation that you can find and videos and stuff like that. You can then access your computer, which is controlling your CNC through your phone. So it's like phone to computer to CNC, and you can like jog and you can set zeros and stuff like that on your phone. So it's pretty cool. We also recently, in the newest version of GSender Edge, which is like, it's kind of like a beta testing version of GSender that people can go and try out. And it's like, it might be a bit more buggy, but it has cool features on it. On the newest version we put out, it's got new forms of joystick control in it. So try it out and give us feedback, but basically it allows you to, on your joystick, like use the analog keys to, or the analog sticks to like move your machine around much more smoothly and set zeros and do hotkeys and stuff on the joystick. So you can try that out too.
Last question.
All right, last question from David Cummins. When will datasheet be available to read over specs and instruction for connecting and using with a spindle? I am currently using a 8 kilowatt water cooled spindle on my long mill and it works great.
Oh, that's great. I mean, if it's already working great on your long mill, it'll work on the SLB. So you don't have to worry about that. If you want to change how the communication interface works, then yeah, you probably would have to wait for that to come out. I'm going to be putting that sort of stuff out once we have the design actually finalized. As I said, we're waiting for the next round of prototype boards to come in, and we feel pretty confident that these will be like good to go, but we would still have to test them and double check. And once we test them and double check, then we can start producing them. But basically, the existing board only had like 2 or 3 things on it that we didn't like that we're changing for the new batch of prototypes. We're just kind of doing like an extra sure check. But yeah, once it's looking good, then I'm happy to start working on putting out the schematics and the documentation. Usually we try to make sure that we have all the stuff available like as soon as we can, like as soon as things are solidified. Obviously it takes a little bit of time to go through and like process it and put it out there, but yeah, we try to put it out as soon as we can. If it's, yeah, I'll try to do it in the shortest time span I can. I already have a very long document that's going through like the wiring, the pinouts, the voltage, the currents, like all the other sort of stuff, because we kind of want to make that documentation just to give it off to the beta testers so that they can set it up and know what the board is capable of doing and test it to its fullest extent. So cool. Maybe I can try searching to see if there's any other questions.
We still have the questions on the sheet too.
That's true. Let me see if I can find any on here first. Is the new longboard, i.e. the super longboard, the same width as the regular board? I think it's pretty close.
Yeah.
I'm not sure the exact measurement. I can't remember. But I think it's pretty close.
But it's not the same.
It's not the same though. Yeah, it's not the same. Is the video still running?
Yeah.
Oh, okay.
They've been watching this whole time.
Yeah, on my screen it's just like the freeze frame of me and Johan.
Oh.
So maybe mine needs
Oh, I
to
think
be...
it's because you're like not watching it live.
Oh, I see. Okay.
Still have over 100 people. Is that? Yeah,
Yeah,
that's people.
I think there's 100 people still watching. Yeah,
Crazy.
It's great to see all you guys in here. Come on, actually.
Yeah, sure.
There's like questions about like the size of the SLB when it's in the new case, and I think for that I can like probably in the near future, like before Christmas, we'll have more information about like sizing and stuff posted, because by that time we'll have some prototype stuff in and we'll have it tested. Obviously the size of the board isn't changing, but like just the size of the enclosure and stuff like that, we can have that out. There was also a question from Jamie Smedley about if the SLB will come with an extra thermal block for people that want to use it with DIY CNCs. In the testing that we've done, the motor drivers, right now they're set to 2.8 amps per driver. I think that's RMS. But if you actually put it any higher than that, then they like drastically increase the chance of thermal runaway, and they don't actually improve the performance of the stepper motors at all. And we know, don't ask us how we know that. It's because we were playing around to see how we could get the speed and the torque settings set up for the Mark II to try to make it run as fast as we could, basically, and then burnt a lot of drivers. So no, there's no plan to ship like a thermal block or anything like that. I think if you're, as I was saying earlier, if your board is able to, like if your CNC runs like similar stepper motor as like a lot of the other DIY CNCs in this sort of price bracket run, you shouldn't have any problems. You shouldn't have any issue with like the current settings. If anything, you could probably reduce them if you want, but I don't think you need to increase them. And as long as you don't increase them, I don't think they'll ever get hot. We've even done testing of the SLB inside a fully enclosed like Tupperware container, running it around for a long time, and it still doesn't overheat. And I think the last thing we were gonna try is like me and Johan, we're gonna try sticking the SLB in like like a toaster oven or something while still running it to see if maybe in like really hot Texas weather it might shut down. But yeah, that's how that's looking right now.
Yeah, it might be important to tell break the misconception, which is that the more current that you put on the motor, it doesn't run better. It doesn't run faster, or it doesn't give it more power. It's like there's a ringing portion where it's like it'll bypass the coils and it'll make things worse. So yeah.
Yeah. There's a point that it reaches where it's like you start shoving even more current through. It's like it doesn't matter. Like the stepper motors have a built-in resistance in their coils that like all you're gonna do is just like heat up the motors more, and when they get hotter, they don't perform as well anyway. So it's just like a built-in constraint of what the performance of the motors is. Yeah. So there was also some questions.
Are we doing a NASCAR switch for the sound again? Okay, they're switching out the batteries for the interface. So enjoy the silence for the next like 10 seconds, 30 seconds.
Yeah.
Yeah.
Is it back again?
Yeah.
Okay. This other question was about the like supporting a Mark II that's 1.5 years old by Ranger 2056. Yeah, and I'm just gonna reiterate, like this board, we are pretty confident it's gonna support every long mill we've ever shipped from back in, what?
No, continue.
Was it like 2019?
Yeah, I think it's 2019.
Yeah.
Yeah.
Like
All of them, just all of them. Don't stop
single-
asking. It's just for all of
everyone.
them. Every single one.
All of them.
Even the very first one.
Like you have to understand that all the long mills we've shipped to date are like electrically quite simple. They're just motors. That's basically it. It's just motors.
Yeah.
And then if you have limit switches, it's limit switches. But every single one that we've shipped, you can plug it in the new board, and it'll immediately make your machine faster and have more capabilities and all this other stuff. It'll work.
Yeah, every single one.
Yeah.
Yeah. All of them.
All of it.
All of them. Like no exceptions.
Yeah. So okay, do you want to do
Except the guy who asked.
Yeah, except you in particular.
Okay.
Yeah, whatever. What the next?
You want another question?
Yeah.
Okay. Will you have the ability to have more than one sensor for the Y limit, so we can use sensors for squaring the machine?
Yeah. So I think I answered this question prior. Basically, we do have an input for a separate Y-axis limit switch. We've already tested and it works. You basically just like take the limit switch that's here and you install another one on the other side. And then now it basically uses the position of those two sensors to square up the machine every time it homes. Because the SLB also technically is like a 5-axis capable board, but it's using 2 of those axes to drive the 2 Y-axes independently. So that's what allows it to do the Y squaring. But basically the reason I'm not guaranteeing it'll be available at the time that the board launches is not because it doesn't work, and it's not because we haven't tested it. It's just because we're trying to prioritize certain functions that we think people will benefit more from and bug test them and all that stuff. And if we get to it before March, then it can still be there. But if we can't, then it'll just come at a later date. But yeah, the input's there. The motors can move independently. Everyone that already has limit switches would need to buy a fourth one for it to work. And we would have to sell a fourth one, or you could buy like a powered limit switch, like an inductive sensor online. And we'd have to make some documentation and stuff like that. So it's just a matter of time.
Well, you'd want to use the same sensor on both sides for consistency.
Yeah,
Because the sense distance will be different depending on the sensor. Yeah.
But yeah, that kind of answers that question, I think.
Oh, will the new SLB support a tool changer?
Oh yeah, this is another question I got quite a bit. Basically, it depends. Like, there's a lot of different tool changers that are emerging in the hobby CNC market right now, which is really exciting. There are some that are like, actually, I have. Do you want to grab? Oh,
change?
maybe Johan can grab it. Yeah. If you guys haven't seen this is really cool. The rapid change automatic tool changing system. And this is actually a tool changing system where you can like take your spindle and like shove the collet in here, and it'll untwist it and then twist on a new one and then do a tool length sense and then keep cutting. And it has like a motorized covering too. We haven't started testing about like supporting this, but it is a potential option. There's other tool changing systems that use pneumatics. There's one that, for instance, like the Pwn CNC guys have put one out that's pneumatically driven, I believe. Basically, I'm still looking into it. I think theoretically, the number of inputs and outputs that we have spare on the SLB means that you can control, like either there's circuitry on the board that you can use to control an automatic tool changer, or it has just enough raw signals that it can go to an external circuit to control an automatic tool changer. Like, I'm pretty confident about that. But I haven't tested it. And at the time of release, it probably won't be set up to work that way, I would probably say. But I'll say once again, it's an open source design. We're using open source firmware. Like, all the stuff is going to be published. We're going to make documentation that talks about like the plugins that we've made and the schematics for the board and all that stuff. And so, like, if you feel confident in what you want to set up on your hobby CNC machine, you can go wild. Like, you can do whatever you want. The same applies for all of our existing stuff that we've put out, like even the existing longboard. You can find all the schematics for this online right now.
Yeah, we actually found a clone.
Yeah, actually, recently we Andrew found someone based out of Switzerland that had taken the design and put their name on it and gave us attribution, which is good because we need the attribution.
That's like a rule.
It's like a rule of the open source design that we put out. We basically just said, you can use it for anything you want, but you have to make sure to publish your designs online, and you have to say to people that we're the people that made it.
Yeah.
Which I think is like a bare minimum.
Yeah. And also, I think it's more expensive from buying it from them.
Yeah.
So,
but anyway, so we've always done this stuff. So at the very minimum, you can probably be confident you can get ATC support. And the great thing about Gerbil HAL as well is like, it's all plugins that are compiled into the core. And the core just has so many like calls and states that the plugins have access to. So I would not be surprised if there's already an ATC plugin for Gerbil HAL that you just compile in, and then it sends all of the necessary signals at the time it needs to do the tool change. And if there isn't, I wouldn't be surprised if it would exist very soon. So, yeah.
We got another question here. Someone asked earlier, but will it be possible to use a bit setter with the new board? And are there any plans for that?
Yeah, so the hobby CNC community has come to know what are more generically called tool length sensors as bit setters, just because like I think Carbide 3D was one of the first people in the hobby CNC market to come out with one, and they called theirs bit setter. But the generic term for it is a tool length sensor. It's basically just like almost like a button that the tool can press. We have one on the table back here that you probably can't see. There's one in here as well that you can see. It's like a button that you can press with your tool. And yeah, we've already done extensive testing. It looks like we'll be able to support it. I don't know if we will like have all of the, like when we're trying to support things at launch, we're not just trying to make sure the board can do it, but we're also trying to make sure that in GSender, it's all set up to work well too. I can tell you that like GSender already has a version of macros that it can run that supports tool length sensors like the bit setter. You can go try it right now, and it works even on like our existing board and other Gerbil based boards. You don't even need the new board for it. The new board actually has some other really interesting stuff about it, which is that it has the ability to store things like tool change macros and other information on the board itself. And so you actually don't need the sender to know how to manage the tool changes anymore. The board actually will manage the tool changes. So if you send like a Gerbil HAL based board, like an M6 tool change command, it'll see that. And on the board side, not on the sender side, on the actual board, it'll say, okay, now I'm gonna run this whole sequence of events to do the tool change, which means like it makes things a lot easier for the computer. Like the computer doesn't have to be handling all that itself. The board actually will handle all of it. So right now, what we've implemented in GSender is a computer side solution, but the SLB also has a board side solution. And the board side solution, we're still playing with making sure we can support it at the time of launch. I'm not going to guarantee it, but yeah, basically what I'm saying to you is that on the software / firmware side of things, very possible, very doable. We'll see where the testing goes, but we still got a whole like 3 months before we start looking at shipping. And on the hardware side, we do have 2 distinct inputs now on this board. On some other boards, like Gerbil-based boards, there's only one input, and they'll tell you that if you want to use a touch plate and a tool length sensor simultaneously, that you just put them both in parallel. But the downside to that is that requires that the tool length sensor you use is normally open and not normally closed. Because if it was normally closed, touch plates usually are normally open, and then it would just be constantly triggering. So the nice thing about normally closed tool length sensors, like why you would typically want to use them, is because if the wire ever like becomes disengaged, then it'll put an error up on your machine. Versus if you're using a normally open tool length sensor and then the wire becomes disengaged, then it'll just go to probe it, and then it'll just like break stuff, basically. So because the SLB now has 2 distinct inputs, those 2 distinct inputs, you can invert either of them. So you can have any combination of like normally open and normally closed for both touch probes or surface probes or whatever, as well as tool length sensors. And they'll all work together. Yeah.
Michael Bees asks, will you be publishing a list of joysticks that can run on the SLB?
So when it comes to joysticks, currently the joysticks are actually what are being supported on GSender. Like the software sender is what's actually supporting the joystick, not the board itself. So we actually already have a list of 2 joysticks in the GSender documentation that are supported by, like we test them for GSender and they work. And we're hoping to like expand that list as we keep going. I'm not sure that we would ever have in the future the ability to like plug a joystick directly into the SLB and it would just work. Yeah, right now it basically you plug the joystick into the computer that's where that computer is plugged into the SLB. So the computer is kind of like routing the commands of the joystick through to the SLB that way. I know there's like a bunch of other interesting ways that joysticks can be handled. I know like the Onefinity can handle plugging a joystick straight in, but also the Onefinity is using the BuildBotix controller, which has a Raspberry Pi inside of it, which is just a mini computer. So you're actually just plugging the joystick into a computer the same way you'd be doing it here. So it's kind of, it all comes out the same in the wash.
We have another question, which is how long is the SLB warranty for? So I wrote like a general warranty for SLB,
Right.
which is going to be, we'll have like a 90-day warranty for it. I think the only like terms is use like if we'll just cover it for long mill because we haven't tested it for any other machines, and you need to use a long mill power supply.
Mm.
And then defects, issues, things breaking and stuff that we'll cover, as we usually do. There should be like a very short list on the product page, so you can check in the FAQ. It should be more details there.
Okay.
Yeah.
Yeah, like I think one of the things we want you guys to understand is like we're definitely not like this is a big foray for us. Like we are typically a very mechanically focused company. I'm very glad to have been working with Andrew from Expatria and his team on this whole design. Like a lot of it has come from a lot of their expertise. And that's actually a lot of the reason why we're feeling quite confident about it is because we trust them very much. And they've designed a lot of excellent boards that are already used in the open source CNC, like hobby CNC community. If any of you have ever heard of the Print NC, a lot of the boards that are used in the Print NC community, like the FlexiHal, those boards are made by Andrew. So he does great work, and that's why we're feeling very confident about the SLB. Really, when we've been putting this board together, it's been a marrying of like our understanding of like all the expertise that we have serving like our users over all the past years that we've been in business, and knowing like what people will want and how people will expect the board to behave and stuff like that. Because even though like Andrew's made a lot of CNC, like hobby CNC board designs, he's not like running a business around distributing them or anything like that. So he just makes them because he has the expertise to make them. So we're kind of able to bring our experience of scale and what we think users will want and adding in those features to the board and stuff like that. And even small things like the compatibility between the old board and the new board, or compatibility between the SLB and other hobby CNCs, as well as we're bringing to the table like all the in-house testing and all of the G-Sender support and all of that other stuff. So at the end of the day, we're kind of like, as you guys know, we're doing this pre-order. We're trying to gauge what the interest is. We're ready, like we're feeling pretty good about it. We're going to be doing more beta testing in the future. We're going to be seeing how the long form testing works out for that. And like we're ready to support this long term. But I think for our first foray into it, we're kind of going to be seeing how the implementation works out, what sort of additional documentation we might want to make depending on how many people buy the board for like external, like other CNCs that aren't the long mill. And I think once we kind of get our feet wet and get a taste for what that all looks like, we can kind of see how we want to change moving forward. But I think what Andy mentions is like a good starting point for like where we're feeling about supporting it for now.
We have another question.
Mm-hmm. Keep them coming.
Yeah.
I'll be here till midnight.
Don't test them.
No, actually don't do that.
We have a question from Kenny, which is on the SLB, could I control a dust shoe up and down independent from the spindle/router?
I guess it depends on how you're planning on controlling that dust shoe. I mean, technically, if you want to drive it with a stepper motor, you could maybe use our 4th axis output and drive it up and down with a stepper motor. If you want to use a pneumatic system, we actually have outputs that can directly control solenoids, like pneumatic solenoid valves, to turn on and off. So you could like drive the solenoid downwards to activate the dust shoe in the cutting area and then release it to pop back up or whatever. So yeah, I think there's a lot of options there for driving that sort of setup.
David Sander asked, do you have an idea of what percentage of speed increase there is over the old board versus the new board?
That's a good question. So when we first put the board out there, we were testing more ideal setups, which is obviously not representative of the real world. But like to give a perspective, like all of the long mills that we ship out right now with the existing long board, the max speed for the X and Y, we set those at 4,000 millimeters per minute and 3,000 millimeters per minute for the Z axis. And then the acceleration for all three axes, or sorry, for the X and Y is 750 millimeters per second squared. And then for the Z axis, I think is 500 millimeters per second squared. And then when we were doing like ideal test case scenarios for the new board, we were finding that we could run it up to sometimes even 10,000 millimeters per minute in the X, Y, and Z. And then for the accelerations, we had it set to 100 millimeters per second squared. So it's like quite a bit faster. But when it came to actual like real world testing, sometimes people will have like a lot of dust on their rails, or sometimes the machine will be a bit more skewed between the two Y axes or whatever. So then that can impact the kind of like idealized speeds that we can run at. So what I can say is like at the very minimum, with the variety of setups that we've had, we've been able to run everything at least at from 4,000 to 5,000 millimeters per minute in the X and Y, and also the Z is running at 5,000. And then the accelerations are all bumped up from 750/500 to 1,000 currently. And the reason why higher acceleration values are great is because when you're doing 3D contour cutting, you basically have a bunch of these like tiny little line segments that the machine is moving along. And for each one of those line segments, it has to kind of accelerate and decelerate on each segment, and then accelerate, decelerate, accelerate, decelerate. So in those cases, it actually doesn't matter how high the max feed rate is. It actually matters more how high the acceleration is. Because if your acceleration is super low, then it's never going to get up to the full speed along such a small segment. And so we're always trying to prioritize increasing those as high as we can go, so that on the 3D cards, that really impacts how quickly the carving times are. Like it reduces them quite a bit. So going from 750 to 1,000 is like a pretty big jump, I think, if you kind of like compare what our setup is versus what some other boards are able to do, or machines that are able to do that are on the market at this price point. And the plan is basically going to be that I think I'm like happy with those baseline values, but we're going to kind of keep working on tuning the motor drivers over the next couple months to see if there's any other tweaks we can make to them, so that we kind of at the start prioritize them for the highest speed. But in retrospect, because the motors can torque out on CNC machines based on like if they're kind of dirty or whatever, the startup torque where it's kind of accelerating at the beginning is where it tends to torque out. We should not have prioritized the tuning for the drivers for speed, and instead of prioritize them to have better low-end torque so that it can get up to speed faster in a variety of conditions. So we're just going to be playing around with the settings to see if we can improve that. And if we can improve that, then we could probably increase the max speed as well. So yeah, and it might also be like, well, it's probably also likely that for the alt mill, if we used like external drivers or internal drivers, like no matter what, those speeds are going to be a lot faster, because it's like the alt mill will be like a more idealized setup versus like the long mill, where people kind of have to set up the squaring of the whole system and the mounting all on their own. So yeah.
Addy Ringer is asking, does the SLB include the compute module?
Oh, okay, Addy, if you go back in the live stream, we talked about this for probably like 20 minutes or something. But we answered the question. Just so you know, like I'm gonna give a short answer now, but I'd suggest you just go back and watch it when the live stream gets published, or you can probably still watch it right now. But there's no compute module on the SLB that we're launching. It's a standalone board, and then we're gonna be releasing a computer to support running it in the future.
Kenny asks, how silent are the drivers on the SLB?
I should probably make a mental note to do like a decibel measurement on them, but I think it is on right now, right?
I think the most of your sound is coming from the VFDs, no?
Yeah, so the sound you're hearing right now, if I lean in, this is like the fan noise coming from the VFD.
Probably turn it off.
The voltage. The transformer.
I don't know if you guys can hear that, but
Should I turn the transformer off?
it's pretty quiet.
You're stepping on
Oh
thing.
my. Peace and
Are
quiet.
you holding? Still holding?
You can see that this is the noise of the holding current on the z-axis. Can you hear that? It's barely there. And this is the noise when I'm moving it. I think I will probably come out with a video. Like we're gonna keep updating you guys on the progress of the SLB as we move through December and into the delivery date. And I'll probably come out with a video sometime between now and then that will show like an exact audio comparison of the existing long mill versus it'll be the exact same long mill, like the machine is the same, but just on one board versus the other board. And roughly, like I would say that the noise level is reduced by like half when the machine is running. Like the motor, the noise coming from the stepper motors while they're moving, I would say is about half. And then if you compare like the holding current, I mean, like when it's holding, you basically don't hear it at all. So like the machine technically, like even if I had all the motors holding right now, it would sound the exact same. It basically, you can't hear it. So yeah.
All right, another question. Colby Browning asks, for using this with the Vortex rotary, it still needs to be switched manually from y-axis to
The a-axis?
a-axis like I do now, or buy an external driver for it to not need the manual switch?
Right. By the way, hi Colby, I know you. Good to hear from you. So to answer your question, we're actually going to offer both options. So you can, if you want to still use the switch, you can still do it the same way the current longboard does it, where you plug the switch into the y-axis outputs, you use the switch, it switches over to the a-axis. So basically the entire process will look the exact same way, and you can just keep cutting. If that's the way you want to do it, it's a completely valid way of doing it. If you want your rotary axis, like if you want to bring it to the point that you can do simultaneous fourth axis cutting, or you want to just like make the process of switching between like of turning on the rotary axis and just doing rotary axis cutting, not full fourth axis cutting, i.e. like you want to do the probing or the alignment or anything like that, and you don't want to have that switch, then in any of those cases, you would need the external driver. And in the case when you have the external driver, you don't need to switch anything anymore. It's like they're all available to be controlled all at the same time. So it's really up to you, because technically if you're like happy with the current process of the manual switch and you already have the hardware on hand for your Vortex and you're happy with it, then you don't need to change anything and you can just keep being happy and call it a day. But if you do want some of those extra abilities, then in that case, yeah, you can get rid of the switch wiring and you would have to get the standalone motor driver, and then that would kind of be like a permanent setup where you don't have to flip any switches anymore.
Jim asks, was tied up till now? Can I watch this in full later? Yes, we'll have it published later, so you'll be able to watch it.
In all of its glory,
Yeah.
in however long, I think it's been almost 2 hours now. You can watch a full 2 hour, or maybe if we keep going longer, you can watch it, you can eat dinner.
Yeah.
You can watch it with your kids in front of the TV. The kids can learn about CNC machines. Maybe you can show it to your wife, or maybe you can show it to your husband, depending on who you are that's using our CNC machines or interested in our new board. Or you can be a kid and you can show it to your parents. There's so many possibilities.
But like all this information, this has been asked like quite a few times, and we have an FAQ on the product page, and we have the other 2 videos like.
Mm-hmm. And we'll have more videos in the future.
Yeah, we'll have
too.
like so much content. It's sort of hard to like get through everything.
Yeah, it's hard to like. We don't have a singular source to answer every single question all at once, because they're.
I mean, technically, the FAQ on the product page like covers all the questions.
Yeah.
Yeah.
So check that.
Yeah, check that out.
Mm-hmm. But I know that you're watching the live stream right now because you actually, it's not just the content, but you just want to see our beautiful faces and hear us talking in a very echoey room. So I understand if you want to see it in video form.
Cool. All right. Well, people are saying thanks to us.
Okay, let me see if there's any other things that I saw here before we call it a day.
I think last I checked, we had over 90 controllers.
If any of you guys are leaving, it's been great seeing you, but we still might answer some more questions before we leave. And if you're just now attending, know that like the pre-orders are available. They've been available since like just before we started, and we don't want to pressure you to buy or anything like that. It'd be great to see if people want it or not. Like we're kind of using the pre-order as a way to gauge support, but the pre-order period is open until the end of January next year. So if you are waiting for it as a Christmas gift or you need to get some money in or whatever, like don't worry about it. Touch. I think this might have been a question that we didn't answer. Dave Cummins asked, when will the hardware be available to attach the board to the Y rail, and will it work with the current board? Oh, I see. The bracket that we designed to hold the SLB on the Y-axis rails for the current board, that design would not work for the existing longboard because it's using like a property of the extrusion that we've designed into the SLB enclosure in order to make it work. If you want to mimic this setup for your existing longboard, it's definitely possible. You basically just use like 2 corner brackets and you use 2 T-nuts. Like we make the T-nuts available only under your hairs in the camera.
It's like, I thought it was a cat or something.
The caterpillars are coming in. Yeah, so you can just like slide in 2 T-nuts and put 2 bolts into the rail here and then bolt them into your longboard enclosure, and that would work just fine. So like I don't know if it is going to be something worthwhile that we're going to put out. Maybe if there's lots of comments in the live stream video, or if you send in messages about it, like if we get enough people asking for it, we might put something out because it's just a simple bracket to attach it. So just let us know.
Ranger2056 asks, if the SLB fails, can I switch back to my old board?
Oh yeah, definitely. Like you literally, the board has no influence over, like it doesn't change anything else on your machine. So if it were to ever break for any reason, you just unplug all the plugs, plug them back into the old board, and you're running golden. That's a huge benefit to how the whole setup is. And actually all of our beta testers, because you know, they were testing the SLBs at the start where maybe the firmware was a bit more finicky or whatever, then if they were like, oh, I've got to run a job for a customer this weekend and I just want to make sure it runs reliably, then they would just pull out all the plugs for the SLB, plug it into the longboard, run the job, unplug from the longboard, plug back into SLB, and then keep doing testing for us. It's pretty straightforward, I would say.
Colby asks, do the first 5 pre-orders get a free t-shirt, LOL? No. Actually, you have to give us your t-shirt if you want the SLB. Sorry, Colby.
Yeah, I mean, we have like a kind of a logo design on the SLB right now, but maybe one out in the future.
3 away from 100.
It's working now? Okay. Thanks for the amazing comment, Techie. Are you guys planning to design any audio systems soon?
Clearly not.
I don't know.
We're totally not qualified.
Yeah, I don't think that would be a good idea. But every time we live stream, I feel like we learn stuff. And also, the amazing thing about the new space that we're moving into is we're going to actually have set up dedicated live stream area so that all the equipment will be there and all plugged in and all that stuff. So then all we have to do is come and sit down and then you guys can watch us. Whereas every time we've live streamed, I think almost every time we live streamed to date has been, we have to reset it all up. And we're like setting up all this equipment usually in like a hectic shop where we're testing things and there's dust everywhere and all that other stuff. So it's like, it can be tricky, but we will keep working forward on it. Yeah.
Bill's asking, by having the board attached to the rail, will it not create some additional vibration on the board?
It doesn't really, like when you look at kind of like the separation, and also because like the machine has to be mounted to like a fairly rigid surface in order to operate, there's not a bunch of propagated vibration that's happening. So we're not very concerned about it. And as I said, we're going to keep doing more long form testing on it over the next couple months to be like extra sure. But I don't think I have any concerns about it being mounted to the rail right now. And to be honest, like mounting it to the rail versus mounting it to the table right next to the machine wouldn't have a big difference in vibration anyway. So if you already are someone that mounts your longboard to the MDF next to your machine, then you basically have already experienced the same thing as mounting it to the rail. It's slightly different. But yeah, I don't really have any concerns about it, I would say. The other aspect is that on the existing board, we had the Arduino like plugged into the bottom side on these pins. And to be extra sure that it didn't vibrate out, we would hot glue it in place. But then sometimes it still might even slip out. But on the new SLB, like everything that's vital is not like plugged in that way. It's all like firmly attached. So I don't foresee any problems happening there. Like there's a lot of strain relieving on the cables that are within the controller, so that's good too. So yeah. Kenny Sweat didn't ask a question. He brought up that he just loves the RGB control for the machine state. And I just wanted to make a comment that I'm really hyped about it too. The cool thing about it is that you can kind of use the onboard LED. You can set up external LED strips. If you want to hide the board away somewhere else, then you can still extend the RGB LED status strip. And I mean, theoretically, you could like put it up on your wall, or you could put it on your ceiling, or you could do whatever. So it's pretty cool to have. It's similar to like a light tower that a lot of industrial CNCs use. But I think it's even cooler than a light tower, and it's way less expensive. The other cool thing about it is that we've introduced custom M codes, and that basically allows you to overwrite the RGB status. There's basically two distinct outputs, one for two different LED strips, because we're figuring that one of the use cases is to put a couple lights around the spindle or the router to illuminate the cutting area. And one of the other use cases is to use a much longer strip to put like under the rail or under the table or on your ceiling or on your wall or whatever. And those can both be controlled independently. And we've got M codes that basically can turn them from like live status update, like RGB stuff, to just constantly white or constantly off. And what's cool about that is we can basically just like put a button in G-Center that says like, light up my work area whenever you finish running a job, and it'll just be fully lit and you can see everything and swap out the work, the material or what have you, like the stock material. And yeah, so I think that's pretty cool too. No more Thor hammers. Disco long mill. Yeah, you could make you could make the long mill disco. You could repeatedly send the off and white commands and just have it like flash or strobe or something if you wanted to. The only thing I will say, just to temper expectations, is we're not making the lights so that you can make them like all different lights. Like, how do I say? You know, like the light strips, they can all be different
They're
colors.
not individually addressable.
Yeah. We're just making it all a single color, because if we wanted to make them individually addressable, it would just take more processing power. And also, we're only making the lights change color when the machine isn't moving. So like when it goes to move, it'll change the color before it moves and then change it back after it's done moving. Or like while it's cutting, if there's an alarm, then it'll stop moving and then turn the lights red. And we're only just doing those things because it's like surprisingly processor intensive to actually manage like these individually addressable LED, RGB LEDs. And we want to make sure that they're not impacting the performance of the machine's movement or cutting or anything like that. But trust me, when you're running the machine, you won't notice. And I think it'll be a really cool first foray into kind of sprucing up hobby CNC machines to the next standard that I think all of you guys and myself and Andy would love to see in the industry, of making the machines more usable and just like kind of more fun and more friendly as well. So yeah. I think we probably have caught up on all the questions. Was there any other ones on there that were worthwhile?
Probably. For Gerbil HAL, how's it supported? Do you need a new post processor?
Oh, right. For Gerbil HAL, like even though the board is running Gerbil HAL instead of Gerbil, the way it's been set up, you can run all existing like Gerbil G-code on it because Gerbil HAL is derived off Gerbil. The only difference is that Gerbil HAL has even more features in it. And so it might be possible in the future we'll come out with a Gerbil HAL like SLB post-processor that you can use in Vectric or whatever other software you're using that can take advantage of the additional features that the SLB has. But there's also ways of taking advantage of those existing features with just regular G-code that's already been made for the longboard. So yeah, that should make your whole process very straightforward. You just keep making your G-code files as you want, and you just take any of your, if you've already made any existing projects that you run on your longboard, when you swap out for the SLB, you can run the same files again, and it'll work the same way.
All right, I think that we have one last one that hasn't been asked. Very interested in the e-stop that will stop the program running. Will you be able to restart the job from the point where it was stopped? Will it be able to keep the job home start position so you could restart the job from the beginning of the job without finding the original home position?
Okay, that's a good question. Yeah, so the new e-stop, so the great thing about the new e-stop as opposed to on the existing longboard, the way we had the e-stop set up, is on the old board, the e-stop just cut power to the whole board, but the Arduino was actually still being powered by the computer. And so that meant that the brains part of the machine keeps running because it thinks that it still has power, because it does still have power. It's coming from the computer via the USB cable. And so that would lead to some confusing situations where when people unpress the e-stop button, the machine wouldn't resume moving because the Arduino was still powered and still running the job in the background. With the new setup, we're making it so that the e-stop is more directly tied, like integrated with the rest of the board. So when you press it, it is still cutting power to the motors as like an emergency thing, but it also is sending a signal to the processor to tell it that the e-stop has been pressed and that it should probably like stop running the program. Now, when that happens, basically that's where G-Sender is actually going to take over. Like the board isn't designed to do power resume right now, but G-Sender is actually designed to be able to handle power resume. So what's going to happen is if you have limit switches or you have a touch plate to an existing position that you are using, you can put power back to the board, like you unpress the e-stop and you clear the alarm. You can rehome or reprobe to the corner that you were using previously. And then basically in G-Sender, there's a button for start from line. And G-Sender can sometimes even prompt you. Like there are certain cases where it can recognize that you lost connection and help you to refine the connection and start at the same place. But when you press this button, because gsender recorded when the e-stop was pressed, where in the G-code file that was, it'll tell you, hey, this is where your program last stopped. Is this where you want to resume from? And then you can click OK, and then it'll just go and it'll keep cutting from where it last left off. So yeah, basically the whole process of resuming job after e-stop is resolved. And we're also looking into if we can, we're also looking into options for introducing this in other situations. Like for instance, if you lose power to your board and your computer and everything, we're looking into seeing if we can make it so that gsender is like actively keeping track of the line that it's on, so that if your computer is powered off and it powers back on, gsender will still remember where you last were cutting. Yeah. Cool. Okay.
Are we good?
I think we're going to stop it there.
Okay,
I think
great.
that's a good amount of. Andy looks like he needs a nap.
I need to go, take a nap.
Yeah. All right. Well,
Anywho.
thank you all. Thank you for everywhere that you came from to watch the stream over the online portal that is your screen. We really appreciate it. Show your interest by, thumbs upping or leaving comments, asking us questions. The video is going to be published to go, like when you leave a comment now, just come back later when the video is published as like a proper video, and you can leave a comment on there, and that's where we'll actually see it. That's like ingrained in YouTube interface.
Yeah, forever.
Forever, for all of eternity.
Yeah.
So go leave it there, or we'll definitely repost the live stream video in other places, and put it on our blog posts and stuff like that. If you want to keep up to date on how the SLB is progressing, definitely subscribe to our newsletter, because that is like the best guaranteed way of getting emails directly from us on updates about the products that we're working on. Or definitely subscribe to our YouTube channel. That's also where videos are going to be coming out showing demonstrations and stuff like that. Tell your friends to buy an SLB if you think it's really cool. Maybe buy SLBs for your family for Christmas.
Great stocking stuffers.
Yeah, is there anything else
Anything else?
from you?
No.
No?
Yeah, I think we shared a lot of information.
Mm-hmm.
And yeah, thanks everyone for coming out, supporting our company, supporting our projects. Hopefully we have some cool boards shooting out into the world soon.
And and also you can keep your ears out for, I'm sure there'll be alt mill updates that keep rolling out, so you can keep watching for that.
Yep.
And and there'll probably be in the description of this video when it's published, links that go to places so you can read more too. And also a link to go and place the order if you want an SLB. Yeah.
Cool.
So goodbye.
Ciao. See ya.
Signing out from Waterloo, Ontario.